proportional relationships.
That's your
Yeah,
present.
I know, but most of it's during the videos that you watch that you fill it in. So
That's your present to us for Christmas.
So, as you are looking at this, it says I can graph proportional relationships on a coordinate plane. We kind of talked about that some yesterday. I can interpret the unit rate. We're going to be looking at that. Use graph tables and equations to determine a proportional relationship. So when something is a proportional relationship, this is kind of an important word up here. What that means, and you're going to notice in all of our graphs today, is that they all start at that point 0, 0. 0, 0 is our start on our graph. So put that with your proportional relationships. 0, 0 is the start. And we talk about what does proportional mean. Proportional means that we are relating two quantities to each other. And as we do that, we're usually, it's a relationship of two different quantities. And when we think about that, usually they have a constant ratio or there's a constant addition or subtraction. So when we talk about our relationship with two quantities, usually they have to have a constant ratio or a constant. And so when we talk about that constant ratio might be that you add the same number each time, okay? So that we are adding 4 each time. Every time we add the same number. Or it might be that we are subtracting the same number. So that constant ratio, it keeps adding or subtracting the same thing. Now, if you take a look down at that next picture, as you are reading, it says, a proportional relationship is between two quantities, and it is one in which the two quantities vary directly from one another. That vary directly, what that really means is they start at 0, 0 on our graph or on our table. Meaning if we have 0 cookies, it's going to cost us $0. When we have 3 cookies, it costs us $1. When we have 6 cookies, it costs us $2.
Oh, 1 cookie.
So, the question is, well, what about if we have 12 cookies? How much should it cost? Should be $4, right? And really, this is how you're thinking of this. The reason this is because we have 3 cookies. If you remember last year, you set up these fractions. 3 cookies to $1 is equal to, and it just said 12 cookies. And if we don't know how many dollars, that's our X. This is what we're trying to find. But I do know that to take 3 times 4 gives us 12. So if I take $1 times 4, my answer here is the $4. Okay? So that's what that proportional, when we're talking about it being a proportional relationship. Starts at 0, 0, and then they give us a ratio, or they give us a, that we are going to be looking at.
Good question. Are we going to give her a test back?
You are going to get your test back.
Yay.
Yep, so right over by. So, I am going to be playing this video, and in the video today, as you are watching, you will notice it says, watch the video and fill in the next 2 slides. So, in this one, as you are working on this, you will be able to fill in this table and you will fill in the graph, okay? So you will fill both these in on this one and then the next one down where it talks about the distance in miles per hour. So you will fill both of these in as you are watching this video, okay?
make sure my volume is up correctly.
You show an infinite number of possible answers. Suppose egg salad costs $5 per pound. Here are 3 possibilities for numbers of pounds and how much they would cost, but you can't list all of the possibilities, so how could you show all of them?
Hang on. We don't want this video. We want.
But you can't list all of the possibilities, so how could you show all of them? In this lesson, you will learn to display all of the possibilities in a proportional relationship by graphing. Let's review what a proportional relationship is. Here's an example, 30 miles every 2 hours. Here's another example, 2 pounds costs $6. The key thing is that you have one type of unit matched with another type of unit, pounds to dollars, for example. And the other key thing is that you can get other examples of pairs within that relationship by multiplying or dividing. For example, if 2 pounds costs $6, you could double or multiply by 2 to get that 4 pounds cost $12. You can do that because it's a proportional relationship. You could also, for example, triple the original and get that 6 pounds cost $18. In this lesson, we'll be making graphs. It's very important that you use equal steps when you make the scales. For example, suppose you wanted to plot these 3 points. It's tempting to want to just use 2, 5, 11 as the labels for the tick marks on the y-axis, but you can't do this because that's not equal differences between those numbers. 0 to 2 is not the same as 2 to 5, and that's not the same as from 5 to 11. So as tempting as it would be to do it that way,
So it is really important that you have to set a constant scale. You either go up by 2s, you go up by 5s, you go up by 1s. Just like these are going by 1s, this has to be a constant, okay? You can't use the numbers that are given in your points.
doesn't work. What you need to do is to count by equal steps. For example, count by 4s, 4, 8, 12. Counting by 4s gets us past 11, which is the largest y-coordinate we need to plot. Okay, so how do we graph a proportional
the one in your
relationship like
notes.
2 pounds for $6? You might start by making a table, weight and cost.
Fill yours in.
There's
They
2
do
and
it.
6. And I'll just use as 2 more examples the doubling and tripling that I talked about earlier.
Okay, so that should be your table that you filled in. Okay, you are now going to plot those on your graph and draw a line.
earlier, although you could use other pairs within the relationship as well. Okay, we keep this table. We set up a coordinate plane. Notice that I've scaled my axes correctly. Weight, or the independent variable, on the x-axis, cost on the y-axis.
And when you do your homework today, this is usually where people don't put the labels. So they leave the X and the Y here, and they forget to put the cost, and they forget to put this part. So make sure and plot all 3 of these, 2, 6, 4, 12, 6, 18, and then you can draw a line. They're going to draw that soon.
And I plot these 3 points. Now here's the key thing. These are not just the only, these are not the only 3 pairs within this proportional relationship. Any ordered pair on the line through the origin that these 3 points lie on will be an ordered pair in this proportional relationship.
So that was key. He said through the origin. That's why I said they always start at 0, 0. Any point on here. So if I wanted to go to 0.8, I could find out how much the cost is going to be for 0.8 of a pound. If I wanted to find out how much 3.1 is, I could find that up here, okay? So
for example, if I take my 2 pounds and my $6 and I decide to divide by 2 so that I get 1 pound for $3, hey, take a look. That ordered pair is also on the line because every ordered pair within the relationship is on the line. The reverse is true also. Every ordered pair on the line is an ordered pair in the relationship. So for example, this point, 3, 9, is on the line, and indeed, if I triple the picture that you see on the screen right now, I get that 3 pounds costs $9. Every single ordered pair on the line, even one halfway between, like this one, satisfies this proportional relationship. And the arrow means that it keeps going. So this is a way to diagrammatically depict all of the ordered pairs in the relationship. We can do the reverse. Suppose
This
you're
is the
given
next
a
one
graph.
down.
How can you name in words the proportional relationship that's described here? Well, you just need to pick an ordered pair like this one. It looks like 2 hours, 30 miles. So you might say 30 miles in 2 hours. But any ordered pair would do just as well. Someone else might pick this ordered pair and say 45 miles in 3 hours. Each of those is a description of the same proportional relationship, even though the numbers are different. So either of those, as well as...
So you should have these two written down. 45 miles in 3 hours, 30 miles in the 2 hours.
many other possibilities would be correct. In this lesson, you have learned to display all the possibilities in a proportional relationship by graphing.
Alright, so as we look at this in our notes, everyone should have had their notes filled in with the 2, the 6, the 4, the 12 on that first one, and the 6 and the 18. And then if I was looking at your graph, I would then see that you plotted your points as you were looking at this with 2 and 6 and 4 with 12
in the middle.
and 6 and 18. And again, that you have this line and that you have your costs and you put what you're talking about and you have your weight so that we can see what you're talking about.
Unit title.
Yes. And they had their title being 2 pounds for $6.
I'm not ready.
We could have had cost per pound. I would take anything along that line, okay? As you take a look at that next one, this is where you had, the first one was 45 miles in 3 hours. And you also had 30 miles in 2 hours. Those are both proportions. Neither one is a unit rate. We're going to talk about what would the unit rate be when we are taking a look at, in this next video, the per one. So when we start looking at per one instead of out of 2 hours, and in this case out of 3 hours that we were looking at, when we start looking at per 1 hour, that's when we refer to it as our unit rate. So the next video is where you're going to fill in the rest of your notes. So as you watch this in the next almost 5 minutes, 4 minutes and 57 seconds, as you finish this, you will fill in the rest of your notes, okay? So the key thing is we are looking at a unit rate using the graphs. So they kind of start with, okay, how many, and when we look at this, and what is this graph showing? So on this page, you're going to define what a unit rate is, and afterwards I'll put this up so if you don't get it written down, you can copy it. You should be able to answer this one. And then it asks what the graph is showing. Is it showing dollars per pounds or pounds per dollar? You're going to circle one of those when you look at that. And you will fill in the rest of your notes that go through the end, okay? So as we take a look at this video, and then the question about getting your test back, yes, you're going to get your test back, and yes, you are going to get your, we'll get Wildcats today also.
How do you find how fast something is going from a graph showing the time that has passed and how far it has gone? In this lesson, you will learn to find a unit rate by using a graph. You've already learned that if you have a proportional relationship like $6 for 2 pounds, you can make a table of values and graph the relationship. You've also already learned what a unit rate is. A unit rate answers how many dollars for 1 pound in this case? Or in general, how many of the dependent variable for one of the independent variable? In this example, we would find the unit rate by dividing 6 and 2 by 2 to get $3 for 1 pound, or $3 per pound. A common mistake is to reverse the variables when giving the unit rate. So for example, if you're looking at this graph, the unit rate is going to be the number of dollars for 1 pound, not the number of pounds for $1. Suppose you have a table and a graph of a proportional relationship. Let me show you 3 very important ways to find the unit rate, all 3 of which are important.
So this is on that bottom of that first page
Since
of
the
the
unit
notes,
rate means
where it says
the number of
numbering the
dollars
3
for
different
1 pound,
ways.
or the number of y's for 1x, you can just find 1 in the independent variable column, or on the graph, and then see what corresponds to it. From either the table or the graph, you can see that the corresponding number is 3, so the unit rate is $3.
So when we look at this, and I'm filling this part of my graph in, first off, what I know here is how many dollars per pound was I looking at in this case. I should have had my unit rate, $3. Definition of a unit rate that you should have filled in should have been a unit rate. When we look at any time we're talking about a unit rate, it means that we're taking the number of the dependent variable. Okay, so when we look at that number of our dependent variable per, this is the division, right? This means you're dividing by 1 dependent variable. Remembering that x, if we are looking at, is our independent, y is our dependent. So what this is really telling us is that when we find the unit rate, we are really taking the dependent. If you're thinking about this unit rate, you are taking your dependent which is your y, and you're dividing it by the independent, which is really your x. And this is per 1 of the x, right? When x is equal to 1 of them. So this graph, what was it showing us? Dollars per pound, or pound per dollar? Should have had the first one circled, right? As we looked at that. Why? Because dollars is on the y-axis per, that's our division. X is our pounds. So here's where they're asking you to put the 3 ways. They just told us the first way. They said you look at the 1 here, and you look at what number it gets to, or you look at this one. So the first way and easiest way to find the unit rate is to find 1 on the graph or your table. And this is always for your independent, right, the x. For your independent variable. And once you find that 1, look at the number that it corresponds to. What do I mean by that corresponds? In this case, oh, this was 3. Oh, 1 with 3, right? So look for the number that corresponds. Okay? As you turn the page in the notes, they're going to give you the second and third way. We will come back and write those 2 ways down, but for right now, I want you to turn so you're on this one because they're going to talk about how do you find the unit rate. They're going to give us 2 more ways of doing that. And then we will, so you'll fill in the rest of your notes, and then when we fill in the rest of your notes, we'll come back here and we're going to put the second way, and then they're going to tell us, well, there's 1 more way that you can find the unit rate. Okay? So we're going to look at those 3 different ways as we look at that.
Dollars per pound. Another possibility is to pick any ordered pair, such as 4 pounds cost $12 and divide. 12 divided by 4, again, gives you $3 per pound.
So on that
Again,
same one,
from the
that's
graph,
another way of
pick
finding
the
it.
ordered pair, find the two numbers that the ordered pair represents, 12 and 4 in this case, and divide, and you get $3 per pound. A third way to find the unit rate is to look at any ordered pair, such as 4, 12, and then say, okay, suppose at the last minute I decided I wanted to buy 1 additional pound. How many additional dollars would that 1 pound cost? From 12 to 15 is 3 additional dollars, so it's $3 for that 1 pound. Or on the graph, suppose you were planning to buy 4 pounds, that would cost $12. If you decide to go with 1 additional pound, that would take you up from $12 to $15. That difference of $3 for that 1 pound is the unit rate. What's the unit rate for this proportional relationship? Well, in this case, the fastest way is just to find 1 on the x-axis and see that 1 hour
Okay, so we're on that next
corresponds
page
to
in your
2
notes.
kilometers. So the answer would be 2 kilometers per hour. What's the unit rate for
We're on
this
that bottom
proportional
one on that
relationship?
page.
Notice that this time there are breaks in the scales, which means we can't
Okay.
just look up 1 on the x-axis because it's not visible. Well, we can use one of the other methods. Pick any ordered pair on the graph, find its coordinates, and divide. 30 miles in 10 hours, 30 divided by 10 is 3.
So we're taking the 30 and dividing it by 10 to, in this one, get our 3 miles per hour. Okay? So this is on the bottom of that page. There's one more on the top of the next page that they're going to go to. It's another one with a broken graph, but this time no labels.
Miles per hour. One more example. What's the unit rate here? This time, not only do we have breaks in the graph, so we can't look up 1 on the x-axis, we also don't have labels for the scales at all, although I will tell you that 1 tick mark equals 1 unit. Here we need to use the third method I showed. Pick any ordered pair on the graph,
So put a point there.
and imagine that
So
you
right
knew
here,
its
put a
x and
point.
y coordinates. To find the unit rate, imagine that you decided that you wanted 1 more pound than you had planned. Find the corresponding
point up
tick
there,
mark
too.
on the y-axis, and
Top
you
of the
can
next
see
page, that one.
that 1 additional pound resulted in a cost of
Point
4
here.
additional dollars.
Point here.
So even without seeing any specific numbers on the axes, we know that the unit rate is $4 per pound. In this lesson, you have learned to find a unit rate by looking at a graph.
So, you want to fill in, going back to this page, they talked about, go back in this page, they talked about 2 more ways. The first one was finding 1. The second one, did anyone have what they had for the second one, that we could use an ordered pair, right? They said you can use any ordered pair. And they gave the example of, okay, at 3, it's at 9. And so, using any ordered pair, what they said is you can take the y coordinate and divide it by the x coordinate. And 9 divided by 3 gives us $3 per pound. Same as we got here. In this first one, we still had, going across from the one, we had $3 per pound. The last method, anyone remember what they said finding the last method? We have to look at how many ordered pairs usually in that last method. We're going to look at, anyone have it from the notes? We're going to look usually at 2 ordered pairs. And when we look at those 2 ordered pairs, what we're trying to see as the independent variable increases by 1. As the independent variable increases by 1, how does the dependent change? So, as you looked at these, give me a thumbs up once you have those three ways. Then we're just going to make sure that you have the rest of your notes filled in. Okay? With actually doing what they said. Okay? So turn to that next page where you got the 2 kilometers per hour once you have this done. So here they said, okay, we're simply going to pick a point. And I think the point they picked, does anyone remember? Did anyone have it marked down what they picked? Time was, does it matter which one? If I go 3, 6, or 4, 8, it doesn't matter, right? So I'm going to use my second method. This point was located at 3, 6. I'm going to take the 6, and just like in Mr. Olson's test, you had to label 6 kilometers for 2 hours. So I came out with, in 3 hours, not 2. So my answer was 2 kilometers per hour. Okay. Putting the labels with them as you work with these, okay? That next one, we can't pick at 9. We don't know what this number is. It looks like 27, but we can definitely pick here, and the ordered pair would have been 10:30. And again, we can use that same way. Take 30 miles and divide it by 10 hours, and our answer came out to be, when we were looking at that, 3 miles per hour. I don't care if you write it as 3 miles per hour this way, if you do it this way, if you write 3 miles per 1 hour, okay? Unit rate, the key thing is you're going to have it being 1 in your denominator. Whereas if I just tell you 30 to 10 miles, that's a common proportion or ratio. It is not a unit rate. And then that last one, this is where I told you to put the 2 points. We have no idea what the cost is, but they said each one is 1. So as I move over 1 unit, what I could see is that I definitely went up 4. So this answer was $4 per 1 pound. Okay? Your homework. Key thing, for it to be proportional, this question says, in 3A, it says, how do you get a proportional relationship? So let's go back to number 1, please. It says, graph the proportional relationship of 3 pounds of egg salad for $2. What is my X? What is my variable X? Is it the pounds or is it the dollars? This should be my pounds down here. So please make sure with all of your graphs that I can see your label. And now what you would want to do is maybe you're going by, this is by 1, 1, 2, and here is going to be 3, right? 4, 5, and then you're going to have your 6, okay? And this is going to be my cost. So on all of your graphs, I need labels. What might we be talking about? Cost of egg salad. Okay. It says how much for 12 pounds? Well, you want to start off with 3 pounds is, in this case, $2. So again, when you do your dollars, you might have 1 and you might put 2, 3, 4, okay? You want to try and be able to show 12 pounds, right? So you want to make sure you can get that 12 on there. This next one just asks you to find stated words of proportional relationship. Notice proportional relationships always start at 0, 0. So when you get to question 3 and it says it's a multiple choice question, which graph is a proportional relationship? It has to start where for it to be proportional? At 0, 0. We must start at 0, 0. That should help you to pick out which one it is. And then it says, describe a situation. Like, distance per time or cost per pound. You get to make up your own situation in 3B. Eric.
What do we have to describe
Yes, you're gonna do the front and back of this page, and then there's one more front and back of the page. But they go really fast, like this one, you're just looking for the unit rate, right? So when you get to number 7 and you find the unit rate, easiest way, you already know what 1 is, go up from 1 and you got your answer. These ones, you might need to use your notes. How do you find the unit rate? Oh, I probably gotta use that second method that we talked about in our notes for finding the unit rate. Well, I'm gonna give you time right now. You got 10 minutes. You should be close to finish.
Lord, wait.
So, use your time